Good morning, everybody, or evening, depending on when you're watching this. Want you to take this opportunity right now, if you haven't already, to either print out the guided notes from Google Classroom, or at least pause each slide as we go through so that you can write down any notes or equations that you might need. Closed captioning is also available, so if you're looking down here on the video, if having some captions, subtitles on here would be helpful, please take advantage of that. So we're going to get started on something that should hopefully feel pretty familiar to a lot of you from previous classes. We're going to look at systems of equations. So here is one example of that over here, where we have multiple equations and then multiple variables. We're going to be looking at a couple different methods this week. The first one is the elimination method, and the goal here is to cancel out one of the variables through multiplication and then subtraction. So again, feel free to pause at any time as we work through this. So the first thing I would hope that you notice about this system, based on previous experience, is that our x terms are multiples of each other. And so that's how we're going to use the multiplication. We're going to multiply the first equation, which by 2, and that's going to give us the new equation 8x minus 6y equals 22. And then the helpful thing here is that we now have equivalent like terms. And some teachers would say multiply this by -2. That's just dealt with by adding or subtracting. Since I multiplied it by +2, that means I'm going to subtract, because 8x minus 8x cancels out. When I subtract the equations, what I like to do is go through and then make sure I'm subtracting each term like this, so that when I cancel out, I know that I'm going to end up with the correct sign. This would be 6y, and then 12 minus 22. So then 10y is equal to -10, and y equals -1. So this is great so far. One thing that's always helpful to remember is we have two variables here, and so we need to solve for both. So now that we know that y equals -1, we could use elimination again, but usually it's easier to just take one of the original equations and substitute in for the y. So in this case, I'm just going to take that original first one, 4x minus 3y, replace the y with a -1 equals 11, right, because we're just substituting that in here for the y, and then solving like we normally would. Careful with your negatives. 4x plus 4 is equal to 11. Subtract on both sides. 4x equals 8, so therefore x equals 2. I'm fine with you just writing it as two separate little equations. Your textbook will often write this as an ordered pair, 2 and -1 in alphabetical order. So, for example, if it wasn't x and y, it would be a, then b, or m, then n, keeping alphabetical order in every term. So here's a problem with a nice set of solutions. Now, we will, of course, run into ones where we either have no solution or infinite solutions. No solutions, you'll notice here that our x terms and our y terms are already ready to be canceled out. 3x minus 3x equals 0, and 2y minus 2y is 0, but then 10 plus 4 is 14. So in our no solutions, we end up with 0 is equal to 14, which is obviously untrue. In this case, we're going to be looking at parallel lines here. If you remember this, so the idea is that they don't have any solutions, they never intersect, so you can just say no solutions. Now you'll notice with infinite solutions, the difference in this example, all I've done is change this last number, but what it means happens is now we end up with 0 equals 0, which unlike 0 equals 14 is in fact always true. And so if we looked at this as a picture, we would have it would look like just one line going through everything. And so some of your teachers might have just said to write infinite solutions. What your book will do and what I would like you to do is to express this as the line it is. So there's two ways to do this. There's either solving for slope-intercept form, which I'm just going to take this first equation and do just that. And so then we get 2y equals negative 3x plus 10 by subtracting over the x term. Y equals negative 3 over 2x plus 5. So that would be the equation for the line. What your book will do is still put it in ordered terms, just where that first term is a generic nothing, and then the y value is the equation using that same variable. So you'll notice here you've got your x and then t. That's not a great looking t, I'll be honest, but it's the same line as we see here. So thanks for sticking with me as we figure out these first note videos. Make sure that if you have any questions, you leave them in the comments below, and if you know the answer for a question that you see from a classmate, feel free to jump in there. Remember to complete your check-in on quizzes for today, and then look for questions on this topic tomorrow. I don't know, smash that like and subscribe button. I'll see y'all later.